Good morning, students. So we're going to see today the last topics of Module 4. Okay, in Module 4, we have learned in the preliminary portion of Module 4 starts with Agile Methodology, the principles of Agile Methodology, and what is the basic difference between Agile Methodology and conventional software development methodologies. We learned one of the agile process model, which is Scrum model, and afterwards we learned about several types of code inspections. Then we learned about testing principles. Okay, and after which we moved on to the two techniques of testing, the black box and white box testing techniques. Under black box we have learned many testing techniques, and under white box we have learned two basic testing techniques, the control flow and data flow. Okay, so those were the portions we have covered so far in module 4, and these are the last set of topics we have in module 4. So that is regarding test automation, defect lifecycle, regression testing, and testing of non-functional requirements. Okay, so these are the leftover topics in module 4. This will complete off module 4. Okay, so we are going to learn this concept of test automation. So, as the word indicates, it's with regard to automating the test cases. Rather than conducting testing manually, we are going to automate the testing process. We are going to use the test cases, we are going to execute those test cases automatically in order to test an application. So automatic testing or test automation is software testing technique that performs special automated testing software tools to execute a test case. Okay, so we are going to use automated tools that will be doing testing in an automated way. It will be exercising the test cases on code automatically. So we have got specialized tools that does this. It will be doing automated testing for you. So on the contrary, manual testing is the testing group, the strategic test group, the testing team will be doing all the test cases manually on the code. Okay, they prepare the test cases, they collect the test data, and they will be executing these test cases on the code manually. Okay, so the test automation is a process of performing these activities with little or no human intervention in order to achieve greater speed, accuracy, and efficiency. So as we all know, whenever we have something that is some task that is normally done manually gets automated, we have more accuracy and speed that is getting achieved. Very same case in the case of testing as well. When we do manual testing, it's error prone and it takes more time, and accuracy is also less. Okay, so very same thing when getting automated, we can do tasks much more faster, efficient, and less error prone. Okay, so for testing as well, we make use of specialized tools. We use specialized tools that can automate the entire testing process. So we have the different types of testing that can be automated include unit testing, functional testing, integration testing, regression testing. Okay, so unit testing we have already seen. What is unit testing? Unit testing focuses on testing the smallest unit of the software. Okay, it is the smallest unit. Now after all the modules or all the components of a software has been unit tested, we'll be combining all unit tested modules and we'll be conducting a integration test. Okay, I will be testing the entire set of small components in component 1. Okay, I will be testing small components through unit test component 2. After I have completed unit test in component 1 and have completed unit testing in component 2, what I do is I'll be combining this component 1 and 2 and will be performing a integration test. Okay, and then we have what is called functional testing. Is nothing but functional testing mainly focus on testing the major functionalities of the software. We have got two categories of requirements we have. One is functional requirement and second is non-functional requirements. Functional requirements are those functions which the software is basically providing to its users. What are the main functions that the software provides to its users? Those are called as functionalities of the software application. Okay, so each and every functionality of the software application is tested through functional testing. Now non-functional testing mainly focus on testing the other aspects, non-functional requirements or non-functional aspects of the software, like its reliability, its capacity, then what else, usability, how user friendly it is, how reliable it is, reliability. So likewise, I often tell the different ITYs are getting tested. Okay, usability, capacity, reliability, all these things are going to be tested. If all these things are going to be tested, comes to be called as non-functional testing. Okay, so the basic core functionality tested through functional testing, and all other requirements, that is the non-functional requirements, if achieved by the application, if or not achieved by the application, is going to be tested through non-functional testing. I provide a lot of input and I see whether the system is able to handle that capacity. Okay, so capacity testing I do, and I provide different sort of inputs, and I try to find whether the application is generating results which are accurate and correct. So I'm testing the reliability aspect. Okay, and how fast the user can accustom himself to the new application, that is a measure of the usability or user friendliness of the software. So we can have the different qualities of the software getting tested, that happens to be called as non-functional testing. Now regression test, I have mentioned it once. See, we'll be seeing it later on in the down slides. So we have regression testing is normally done after I make some changes to the code. Okay, if I am making some changes at some portion of the code, I'm making some changes, I'm making some enhancements, and then what I do is, I'll be immediately after the changes have been made, I will be conducting a regression test. So my motive behind conducting a regression test is to ensure that the changes have not created any drastic errors. It has not changed the normal functioning of the software. Something which was functioning normally cool, it was working perfect. Okay, by the time I wanted some changes to be made as per the request of the client, so I'm changing the code here and there. Now after that, I'll be doing a regression test to ensure that the software is still working. Okay, it's still working. The change that I've made has not created any drastic changes. Okay, the changes have not turned to be drastic, so that the normal functioning of the application was affected. So that is going to be tested. The change should be made in a proper way, so that the change won't affect the normal functioning of the application. So that is ensured through a regression test. So a regression test always follows a change. Now smoke testing, see, this is one kind of testing technique which also can be automated. Okay, these are set of testing techniques. The testing techniques that we are discussing so far are those testing techniques which are worth automation. Okay, now smoke testing is, see smoke is an indication of some indication that something is working. Okay, if a machine if it is giving a smoke, it means that it is working. And a vehicle, if it moves forward and from the back you can see smoke coming out, it means that the engine is working. So likewise, a smoke testing generally ensures that the software is working. It's not actually suspended because of any error or any defect or any correction, a change is made. The software is not working. Okay, in order to ensure that the software is working, whether the working is correct, that is not ensured. Only thing is that software is working. In order to ensure that the application is working, whether it is working in the correct way or whether it is generating the correct results, is not the concern of a smoke test. A smoke test just ensures that the software is working. Fine. Now, why do we automate? Why there is a need to automate testing? Okay, so test automation is the best way to increase the effectiveness, test coverage, and execution speed. These are the three things that automation guarantees: speed, accuracy, and test coverage. Now, automated testing is important due to the following reasons. Now, one, manual testing is always erroneous. Okay, it will be erroneous, error prone, and it will be time consuming, money consuming, and it is difficult to test for different language code. When we write the code in different languages, we got to adjust our test cases accordingly. We got to find people who are accustomed to with code in those languages. Okay, so multilingual test for multilingual sites manually, it's difficult. Now test automation does not require any human intervention. Okay, so automated test can be unattended. You can conduct it overnight. You don't require the intervention of a human. So automated tests can be done overnight. Then test automation increases speed. Yes. Then automation helps us to increase test coverage. And next is manual testing. As in when we perform more and more tests, the procedure becomes boring and error prone. Okay, so in order to avoid all these, in order to improve the efficiency, test coverage, speed, in order to do things more cost effective, time bound, you can resort to automated test. Fine. Then it doesn't require human intervention, another main plus, so that it can be conducted overnight. Now, which test cases to automate? So when we are trying to automate test cases, what are the different types of test cases you can automate and what are those which you cannot automate? Okay, so we'll be automating these test cases that fall under the following criteria. High risk, all those applications, high risk applications, critical test cases, high risk cases, that is prioritizing. When we prioritize certain functionality, all those functionality which are critical functions of the application, those critical functions can be tested very fast through automated test cases. Now, test cases that are repeatedly executed, those test cases that I want to execute repeatedly, that can be automated. Then test cases which are very difficult for manual testing. Okay, so very difficult and tedious to do manually, those can be automated. Then test cases which are time consuming can be done much more faster when automated. Okay, so these are the characteristics of certain test cases which you can automate. Okay, all those high risk test cases, those which are very vital to be completed on the speculated time, then those which have to be executed repeatedly, those which are very difficult, tedious and time consuming, these can be automated. Okay, now we come across the category of test cases which are not suitable for automation. Okay, so test cases which are newly designed, has not been executed at least once. I have prepared a test case, new test case, and I have not yet executed this test case manually. Okay, I have never executed this test case, so it is not worth automation. A new test case which has not been executed at least once cannot be automated. Okay, I should automate a test case that has undergone couple of executions. Test cases which requirements are frequently changing. If my requirements are frequently changing, if I want to test those requirements, the test cases that are used to test those type of requirements should not be automated. Okay, so test cases which are used to test ever changing requirements should not be automated. Then test cases which are executed on ad hoc basis. Okay, I want to have certain test cases to be executed on ad hoc basis, that is based on a certain pattern, as per certain plans. So I should not automate such test cases. It is adjoined with some other test case. So I should not automate such test cases which are designed for ad hoc cases. Then automated, what are the different steps in automated testing process? First one is I'll be selecting an appropriate tool that can automate the testing process. Then I got to define the scope, which all portion of the code or which all functionality of the application is going to be tested automatically, which all features are going to be tested manually. So I got to define the scope for automation. Then I got to plan, design and develop test cases. I got to do the test execution and I got to maintain test cases. Okay, I got to shift the test cases accordingly to suit my code. Okay, so these are different steps in the automated testing process. The test tool selection, scope of automation, where exactly the test cases, automated test case can be used in which portion of the code, which portion of the code should be tested manually, that I can decide. Then I got to plan and develop test cases for automated testing. I got to do the automated testing and maintenance. Now, what are the benefits of automated testing? We have seen, okay, 70% faster it is, test coverage is more, reliability is there, consistency is there, time and cost savings are there, accuracy is improved, human intervention is not required, efficiency is improved, better speed in executing each and every test. Then the test cases are reusable, test frequently and thoroughly. Then more cycle of execution can be achieved through automation. I can execute test cases rapidly, so more number of test cases can be executed within the shorter period of time. If I'm doing it manually, it takes more time, so that the time taken for me to execute 2 test cases on a particular portion of code, that very same time I can execute 4 or 5 test cases when it is automated. So since it can be done fast, I can think about more test cases to have more test coverage. Then easy time to early time to market. So if I'm going to put the particular application into market, then I'll be having earlier time to market. That means I can put the application much more faster into the market, because testing will be over much more faster rather than manual testing. Then what is meant by the second? So automated testing is that. Now we are moving on to defect life cycle, the second topic. So automated testing mainly focus on automating the test cases so that testing becomes much more simple, faster, efficient, time and cost savings also will be there. Less human intervention, more reliability will be there. More test cases can be executed to guarantee maximum test coverage. Fine. Now we are going to have the next topic, which is defect life cycle. So it is a cycle through which a defect goes. See, I've told you before what is meant by an error and what is a defect. Okay, all those errors which are normally found out before deployment happens to be called as errors, and all those which are detected after deployment are normally called as defects. Okay, now what are the different stages through which a defect goes right from its detection to its correction? Okay, so those are the stages in the defect life cycle. Okay, the stages through which a defect goes right from its identification to its fixing or correction happens to be called as defect life cycle. Now it starts when the defect is found and ends when the tester ensures that the defect is closed. Now after ensuring that the issue is fixed and it won't occur again. Okay, so a defect life cycle, the first stage is the stage at which I find the defect out, and the last stage is the closing of the defect, when the defect has been fixed forever and the tester will guarantee that such a defect will never occur again. Now defect status. Defect status is the current status of a defect, where exactly in which stage of defect life cycle the defect is right now in. That is the defect status. The goal of defect status is to precisely convey the current status or progress of a defect or bug in order to better track and understand the actual progress of the defect's life cycle. So when exactly when I tell that a defect is in this particular stage, I can ensure where exactly the defect is right now, what is the progress of the defect life cycle, when exactly I can expect the defect to be fixed. What are the stages the defect has covered through, and what are the stages it has to yet cover before it is getting fixed. So any particular defect stage of a particular defect can tell you about the position wherein the defect is in the defect life cycle, the time it will take more to have the defect fixed, how long the defect has traveled through the life cycle. Okay, so in order to have an indication about the status of a particular defect at a particular point of time, I can find it out by referring to the defect status. Now the number of states that the defect goes through varies from project to project. Now these are the common states. So we generalize the stages of a defect life cycle into: first stage is new, that is when a defect is newly found. Okay, when a new defect is logged and posted for the first time, it is assigned the status new. We have discovered the defect for the first time, it is logged for the first time, it is entering into the state new. Now assigned is the next state. It means that when a bug is posted by the tester, the lead tester, the head, he will be approving the bug and assigns the bug to the development team. Okay, that is assigned means the bug has been taken by the testing head and he has assigned the correction task to developers. Okay, now open is the stage when the defect fixing is started by developers. Developers have started working on the defect and they are trying to fix it. So that is the state at which a defect is said to be open. Okay, when a defect is first identified, it is in the new state. Once it is assigned to a development team by the testing head, it happens to be in the assigned state. And when the development team has started working on the defect in order to fix it, the defect will be in the open state. Now next is fixed state. When the developer makes a necessary code change and verifies the change, he can make the status as fixed. So once the developer has found out the root cause of the defect and has tried to change the code there in order to fix the particular defect, then it is going to be in the fixed state. Okay, I've found out the root cause of the defect and I've altered the code out there. So it is in the defect is in the fixed state. Now, pending retest state. So once I've corrected the bug, I got to test it again. Once I've fixed the defect, I got to test the application again to see whether the defect has been perfectly fixed. Okay, so for that I require a retest, a defect retest. So defect will go to a retest state once the defect has been identified and corrected and fixed, and I'm going to ensure that the defect is closed forever and it will not come again. Okay, so once the defect is fixed, the developer gives a particular code for retesting the code to the tester. Since the software testing remains pending from the tester's end, the status is assigned as pending retest. Okay, so developer has corrected the code. Now it is given to the tester to test it again. Okay, the developer's work is over. Now the work is pending with the tester to test the code again to see that the defect has been fixed. Now retest, that means that the defect is now the code is now getting retested to see that the defect has been fixed. So when the retest starts, the defect will be in the retest state. So tester does the retesting of the code at this stage to check whether the defect is fixed by the developer or not and changes the status to retest. So when the tester has started retesting the code to ensure that the fixing done by the developer has corrected the defect fully and the defect will not come again. That is, the retest procedure has been initiated by the tester. Then the defect will be in the which stage? Retest state. Then next is reopen state. Okay, defect will be in a reopen state even after, if it persists even after the developer has fixed. Developer has done the fixing of the defect, but in the retest, I have identified the defect again. If the defect is still persisting, okay, if the defect is still there, the fixing is not proper, then the defect will be in the reopen state. Okay, the developer has told that he has fixed the defect, so that the tester is doing a retest. Now during retest, the defect comes up again. So that means that the fixing is not proper, so that the defect is being identified again. So the defect will be in the reopen state. So it will be going through the reopen state. Now closed state. It will be a defect will be in the closed state when it no longer exists and the tester has assigned the status closed. Okay, so once we have a reopening, what happens is developer will work on the defect again. He will try to fix the defect again. Now once the fixing is perfect by the developer side, retesting again happens by the tester, and in the retesting the defect is not coming up again. It has been fixed forever. Then the tester will fix the defect stage as closed. Now second is next stage is duplicate. If the defect is repeated twice or the defect corresponds to the same concept of bug, the status is changed to duplicate. Okay, if after some time I have the same type of defect coming elsewhere in the code, then I can call it as a duplicate defect. Yes, I have identified this defect before at some point of time in some point of code and have corrected and closed it, but at a later point of time the very same defect is appearing somewhere else in the code, then it means that the defect is in the duplicate state. It's coming again, the very same defect found again. Then it is said to be duplicated. Then the next state is verified state. The tester retests the bug after it is got by the developer. If there is no bug detected in the software, the bug is fixed and the status is verified. So when exactly a bug is going to be corrected by the developer and handed it over to the tester will retest it again. So when this retest process is actually happening, the defect can go into a verified state. Okay, the tester will verify that the defect is not coming back during retest. It is fixed forever. Then I can put a different state to the defect as verified. Whatever correction that has been made by the developer in order to fix the defect, that is verified by the tester. So that is the verified state. So it doesn't mean that all these states will be there for all applications. It's totally dependent upon the type of project and type of defects we identify. Okay, so a defect may or may not go through all these stages. It is dependent upon the type of defect and the type of application that we are testing. Next is rejected. Rejected stage means that certain bugs or defects may not actually be a defect. നമുക്ക് ഡിഫക്റ്റ് ആണെന്ന് തോന്നും, പക്ഷേ ആക്ച്വലി അതൊരു ഡിഫക്റ്റ് ആവണമെന്നില്ല. അപ്പം അങ്ങനെയുള്ള ഡിഫക്ട്സ് കറക്റ്റ് ചെയ്യേണ്ട ആവശ്യമില്ലല്ലോ. സോ ഇറ്റ് വിൽ ബി റിജക്റ്റഡ്. സോ ഇഫ് ദ ഡെവലപ്പർ ഫീൽസ് ദാറ്റ് ദ ഡിഫക്റ്റ് ഇസ് നോട്ട് ജെനുവിൻ, ഇറ്റ്സ് നോട്ട് എ ജെനുവിൻ ഡിഫക്റ്റ്, ദെൻ ഹി ചേഞ്ചസ് ദ ഡിഫക്റ്റ് ടു റിജക്റ്റഡ്. ഒരു ഡിഫക്റ്റ് കോട്ട് ചെയ്തു, പക്ഷേ അതൊരു ആക്ച്വൽ ഡിഫക്റ്റ് അല്ല എന്ന് ഡെവലപ്പറിന് ഫീൽ ചെയ്യുകയാണെങ്കിൽ ഇറ്റ് വിൽ ബി ഇൻ ദി റിജക്റ്റഡ് സ്റ്റേറ്റ് ബിക്കോസ് ഇറ്റ് ഇസ് റിജക്റ്റഡ് ബൈ ദി ഡെവലപ്പർ. ദ ഡെവലപ്പർ വോണ്ട് ഫിക്സ് ഇറ്റ് ബിക്കോസ് ഇറ്റ്സ് നോട്ട് എ genuine defect. Now next is deferred. Deferred means it won't be corrected right now. It will be corrected only at a later point of time. We are deferring the defect fixing at a later time. So the bug is present is not prime priority. Atra priority ullor bug alla, so that the fixing of that is going to be postponed to a later time. So we are deferring defect fixing for the time being. ഇപ്പോൾ നമ്മളത് ഫിക്സ് ചെയ്യാൻ ഉദ്ദേശിക്കുന്നില്ല, ഹൈ പ്രയോറിറ്റി ഡിഫക്റ്റ് അല്ല, അപ്പോൾ കുറച്ച് പിന്നീടായാലും ഫിക്സ് ചെയ്താൽ മതി എന്ന് പറഞ്ഞ് മാറ്റി വയ്ക്കുന്നു. ഓക്കെ, ദാറ്റ് ഈസ് ഡിഫേർഡ് സ്റ്റേറ്റ്. നൗ നോട്ട് എ ബഗ്, ഇറ്റ്സ് അനദർ സ്റ്റേറ്റ് കോൾഡ് നോട്ട് എ ബഗ്. If it doesn't affect the functionality, any defect that doesn't affect the functionality of the application can be treated as not a bug. Okay, so it is another state in the defect life cycle, not a bug. It means that if any of the defect that has been detected is not affecting the functionality of the application, then it can be treated as not a bug. Now these are the states, diagrammatic representation of the states we have. Okay, so we have the new state, assign, open, anything that can be open can be reopened again, then fixed. Then from open I can go to duplicate, then rejected, deferred, then I can have next release, then test, verified, closed, etc. So these are the different states we have seen so far. So in agile development, testing need to be early. Okay, testing is done whenever you develop a new functionality. The testing of that happens then and there. It's not like in the conventional model, phase by phase testing comes till the very end. Only after the entire development of the code, testing starts. But in agile methodology, testing is done then and there. As and when we develop new features, they are going to be tested very fast, immediately, and they are going to be delivered to the client. So instead of waiting the development to be finished before testing begins, testing will be happening continuously as features are getting added. So as in Scrum methodology, as in when each features are going to be developed as sprints, what happens is after each sprint has been developed, the sprint is tested and the sprint is going to be deployed. So tests are prioritized like user stories. So testers aim to get through as many tests as they can in an iteration. So whatever functionality I'm going to develop, according to the priority I'm going to develop the functionalities of an application. So testing of the application's functionality as and when they are getting developed, the testing also will be happening simultaneously in the case of agile model. Regression testing, I've already told you, regression testing is to verify whenever I make a change to the code in order to make sure that the change has not created drastic errors or side effects, I will be doing a regression test. So whenever I make changes to any portion of the code, then I will be following that particular, after I make the change, I will be doing a regression test to ensure that the changes have been made perfectly. The changes have not created drastic side effects. So the purpose of regression testing is to verify if code change introduced defects to the existing functionality. So there are many kinds of possible changes that can impact the functionality of an application. Even the simplest change to the code can make a previously running functionality. It can create errors in a functionality that was already running. Okay, so when I make a change, the functionality won't run after the change has been made. Okay, so not to ensure that everything is fine, I do a regression test. So regression testing is performed when there is a code change in the software application. Regression testing involves test the program's functionality to see if anything changed when you added the new code. Regression testing is used to validate the updated software against the old set of test cases. Regression testing helps to ensure that the change has not introduced any unintentional behavior or added errors. Okay, so I got to ensure that my change has not created any drastic errors, side effects or unintended behavior to the application. And also it will be in order to do a regression test, what I do is the updated application, that is after I make a code change, the updated application will be tested against the old test cases. So regression testing, the development process. Okay. Now testing non-functional requirements. Okay, testing non-functional requirements. So for this, what we do is non-functional requirements are going to be tested through non-functional testing. So non-functional testing is a type of software testing that focuses on testing the non-functional requirements of a software application. Now what are the non-functional requirements? These IT-wise: security, availability, integrity, efficiency, reliability, survivability, usability, flexibility, scalability, reusability, interoperability, portability. Okay, these are the non-functional requirements. So testing the application to see whether these non-functional attributes of the software are properly met will be doing the testing technique called non-functional requirement testing. Okay, so non-functional requirements testing, that is non-functional testing, will be done in order to guarantee accomplishment of non-functional attributes. To check whether my application is satisfying all the non-functional requirements, I'll be conducting a non-functional testing. Okay. So non-functional testing include baseline testing, complaints testing, documentation testing, endurance testing, reliability testing, load testing, localization testing, internationalization testing, performance testing, etc. Okay, so some performance testing we have seen, baseline testing, compliance testing, documentation testing. These are several types of non-functional testing. You can study any 4 or 5 and you can code it as example for non-functional testing. Okay. So these are some of the testing technique. Performance and scalability. It will be testing how fast the system works, the performance of the system is getting measured, and how much performance is degrading if I'm adding more input or I'm adding more workload to the system. With higher workload, whether the performance is degrading. Okay, portability in sense I'm porting the application to a new environment, hardware software environment, whether it's working perfect, whether it is compatible with the new environment. Then availability, reliability, maintainability in sense reliability means whether the results generated by the application is accurate and reliable, whether it is the service of the application is available 24/7 without any downtime. Then maintainability, how easy is to maintain the application. Then security, the security aspects of the application is getting measured. Localization, how does a system match local specifies. Okay, whether it is meeting the local requirements of the application. Then usability, how user friendly the system is. So these are certain examples of non-functional testing. You can just go through, and that is all regarding 4th module. So thank you for your patient listening.